You know, in the history of data, there are these moments, these systems, that don't just store information, they completely redefine it. Today, we're going to dive deep into one of those giants, the database that literally dragged forensic science kicking and screaming into the digital age. We're talking about the FBI's Integrated Automated Fingerprint Identification System, or as it's better known, IFIS. So, to really get a grip on just how big of a deal this was, I want you to picture a specific day. We're going back to July 28th, 1999, because on this day, something happened that, believe me, would have sounded like straight-up science fiction just 10 years earlier.
And that right there is the revolution. Think about it. A process that used to depend on human eyes, on magnifying glasses, slogging through months of backlog, was suddenly done by a machine in the time it takes to brew a pot of coffee. This was the day the FBI flipped the switch on the biggest biometric database the world had ever seen. It was a brand new era for digital identity.
So the big question is, why? Why did they need something this massive, this revolutionary? Well, to get that, you have to understand the crisis they were facing. They were, and this is no exaggeration, drowning in an analog nightmare. And the existing system, the National Crime Information Center, or NCIC, it had a fatal flaw. And the whole problem, the core issue, came down to the data itself. See, NCIC, which was absolutely brilliant for its time, it stored text. We're talking names, dates of birth, license plates. But what's the problem with text? Well, you can fake it, right? Criminals use aliases all the time. But fingerprints, that's a different story. That's biological fact. It's a unique identifier that you just can't change.
And when I say they had millions of them, I mean they were literally drowning in paper. Try to picture this. Entire rooms, basically warehouses, just crammed with file cabinets the size of shipping containers. And every single one was just stuffed to the brim with these old paper fingerprint cards. It was a total physical analog nightmare.
Okay, so how do you search through this mountain of paper? Well, the process was, and I'm not kidding, shockingly old school. They were using something called the Henry classification system, a totally manual method for sorting fingerprints that was invented, in the 1800s. Just let that sink in. They were trying to fight late 20th century crime with 19th century tech. And this problem, it was only getting worse fast. By 1989, the FBI was getting hit with over 30,000 of these paper cards every single day. The backlog just kept growing, stretching into months and months. I mean, the system wasn't just slow at this point, it was about to completely break down. All right, so the Bureau knew that just hiring more people to file cards wasn't going to cut it. Not even close. They needed a total paradigm shift. They needed a new kind of machine intelligence. And that realization led to this incredibly ambitious project to build a completely digital system right from scratch. So the project officially kicked off in 1991. But look, this was a marathon, not a sprint. It took almost a full decade to pull off. And they weren't just writing new software. They had to invent entirely new hardware and the incredibly complex matching algorithms to make it all work. It all finally came together with that big launch in 1999. Now, you can't just start scanning millions of records without everyone agreeing on the rules, right? You need a universal standard. So they built one. The FBI laid down the law. Every single print had to be scanned at a minimum of 500 DPI, and only on FBI-certified hardware from companies like Identix and Cross Match. Those scans were then packaged into a very specific DAIA format, the ANSI/NIST Type 9 record. And that, right there, became the new gold standard for digital fingerprints. Okay, so they've got this new digital standard. But how in the world does a computer find one specific fingerprint in a database of tens of millions? The answer is actually pretty counterintuitive. The secret was to stop looking at the whole fingerprint. What it did instead was use something called Minutiae-based matching. See, instead of trying to compare two whole complex images, which is super slow, the software was programmed to find and map just the unique points. These are called minutiae. A good way to think about it is like a connect the dots or a constellation of unique markers on your fingertip. That's all the computer cares about. The whole process was this beautiful four-step piece of engineering. First, you scan the print at that 500 DPI standard. Then the algorithm gets to work extracting all those key minutia points. Step 3 is the real magic. Those points get converted into a mathematical template, what we call a vector. And this is the giant leap forward because the system isn't comparing pictures anymore. It's comparing pure math. And comparing math is just infinitely faster. So what exactly are these minutia features? Well, we're talking about really specific, tiny details. Things like a ridge ending, where a line on your finger just stops, or a bifurcation. That's just a fancy word for where one ridge splits into two. The system also maps out the bigger patterns, like the core and delta points, and even the overall ridge flow. Put it all together and you get a totally unique digital signature for every single fingerprint. Now, you can probably guess this kind of work required a ton of computational horsepower, especially for the 90s. The backbone of the whole thing was a bunch of powerful Sun Enterprise servers. But the real secret sauce? That was in the custom-built ASIC matchers. These were specialized computer chips that were designed to do one thing and one thing only: compare those mathematical fingerprint vectors at absolutely blinding speed. The whole system was a fortress, built from the ground up for nonstop 24/7, 365 operation. So the theory was brilliant, the engineering was solid, but what about the results? Did it actually work in the real world? Well, this is the part where IAFIS goes from just being an ambitious project to a full-blown revolution for law enforcement. Right out of the gate, at launch, the system could chew through 62,000 new 10-print submissions every day. Remember that 30,000 number that was crippling the old system? This was more than double that capacity. That massive backlog we talked about, it was about to be completely obliterated. And the speed difference was just staggering. I mean, look at this. A process that took days, sometimes weeks, was now happening in minutes. A standard 10-print submission? You'd get a response in under 30 minutes. A latent print from a crime scene? A potential match in under 2 hours. This wasn't just a small improvement. It completely changed the speed of police work, turning cold cases hot and identifying suspects before they even knew we were looking for them. And how was this even possible? Because deep inside those servers, the system was churning through millions of those vector comparisons every single second. For its time, there was just no question. This was one of the most powerful biometric identification systems on the entire planet. But here's the thing about technology, right? Even a revolutionary system eventually hits its limits. Tech never, ever stands still, and IAFIS, for as powerful as it was, started to show its age and its limitations by the late 2000s. And its single biggest limitation? Well, it was right there in the name. The Integrated Automated Fingerprint Identification System. It was designed to do one job, and man, it did that job brilliantly. But the problem is, crime scenes have a lot more than just fingerprints. All these other biometric identifiers were quickly becoming critical tools. I mean, palm prints, they're actually found at crime scenes way more often than fingerprints. You had facial recognition technology that was getting better and better every day. Iris scans were emerging as another totally unique identifier. And on top of all that, the core architecture of IAFIS just wasn't built for the coming wave of cloud computing and AI. So IAFIS had proven the concept. It showed that massive nationwide biometric identification was possible. But the FBI's next challenge? It was even bigger. They didn't just need a fingerprint system. They needed a system that could bring together all of these biometrics: fingerprints, palm prints, faces, irises, and search them all in one unified database. I mean, what would a system like that even look like? Well, the answer to that question was a project called Next Generation Identification, or NGI. This was going to be a modern biometric supersystem, one that would swallow IAFIS whole and expand its capabilities in ways people could barely even imagine back then. And that, well, that's a story for our next deep dive.